Hello, my name is Justin Noel. I'm an authorized Qt instructor from ICS. This video is actually a very small sample of a much larger training course called Qt Essentials. In this video, I'd like to give you some key insights on how to use Qt in your everyday projects, and also demonstrate the type of in-depth training available from the full multi-day Qt Essentials training course. In this video, we're going to talk about 3 topics that are going to allow you to easily round out your application. We're going to talk about QSettings, which is a system for saving user preferences that will persist between runtimes. We're going to talk about resources, which is a way to package all your application support files inside your actual application binary. Finally, we're going to talk about deploying Qt applications, which files you need to actually install on the user's system for them to be able to actually use your Qt application. So QSettings is a very easy class to use. What happens behind the scenes is that QSettings allows you to save name-value pairs and a little bit of grouping to save user preferences to the system, such as the font the user wants to use in your application, maybe the location of the windows when the user last closed the application. Behind the scenes, Qt is actually going to use a platform settings mechanism. On Windows, it uses the system registry. On Mac, it uses the Preferences API. And on Unix, it uses its own file system that looks like an ini file that's located in your user's home directory. Typically, you are going to create an instance of QSettings on the stack. You can simply create it anytime you need it. Behind the scenes, there is only one settings engine, and your QSettings instance will access that one single settings engine. Now, to organize your settings, you really ought to provide Qt with some information about your application. QCore application, which is what Q application derives from, has some static methods that you can use to set information about your application, such as the application name, your company name, and your company's domain name. It is going to use this information to save your settings, so the next time your application loads, it knows where in the hierarchy to find your settings versus the settings of other applications. Using Qt settings is extremely easy. Once you have an instance of settings, you can simply set a value, giving it a key. Now, the key can be something simple like value, or it can have slashes in it. And when you use slashes, you're making a group and then a key. So here in this example, we're saving something called group/value, and it's going to be set to 68. Now, the next time this application is run, or anytime we make another instance of QSettings, if we ask for the value of group/value, we're going to get back a Q variant, which we learned earlier is much like a typed void star. It is something that could be any value, and you can ask for the type of that value and get the original contents back. So here we know that group value, we saved an int, so from the Q variant returned from settings value, we can say toInt, which is going to give us the actual integer back. Now, sometimes you might have a very deep hierarchy of groups, and it's a lot of typing, and could be error prone to type in group/group/group before all your value keys. To get around this, you could use a function called beginGroup. So you would begin a group on the settings, maybe called MainWindow position. And under MainWindow position, you would save the width, the height, and the X and Y location to where the main window is stored. Once you're done with the particular prefix, you can call endGroup, which will reset back to regular string keys, and if you want to use the slash syntax, you can. You can even mix and match these different strategies throughout your application. So here's an example of taking a MainWindow subclass and saving its last position. So maybe on exit, you may call exactly this code so that when your application restarts, the main window is in the exact location where the user last left off. So QSettings uses QVariant, and QVariant actually supports a lot of data types, not only the integrals such as ints, doubles, and strings, but things that are ubiquitous in Qt, such as QSize, QPoint, QRect. All of these things can be saved and stored in QSettings. So in this particular example, we're making our settings on the stack, and we are setting the value of main window size to a QSize. Likewise, setting the value of main window position to pause, which returns a QPoint. Now, maybe in our constructor for the main window, we want to make sure our window is now going to be in the place where it last was. So here we do the opposite. We create an instance of QSettings just right on the stack. It's very lightweight. And here we're using begin group instead of using the slash syntax. And once we set a group, we can now use the simpler version of the keys. So we're going to resize the window to the value of size. Likewise, we're going to move the window to the value of pause. Now, you look at these method calls and you'll see that there's an extra parameter to value that we didn't see on the previous slide. This is the default value should there be no setting at all. So maybe the user is running this application for the first time, so there was never a position from the last time. So here the default value for size of the window is going to be 400 by 400, and the default location is at XY 200, 200. Likewise here, because we are using the begin end group syntax, we need to make sure that at the end of our QSettings we call end group. Now, I made mention of this earlier, that the back end for QSettings is going to be different depending on the platform that you're on. On Windows, you're going to use the system registry. On Unix, you get these special ini files. And on the Mac OS, you use the preferences API. This is all going to be taken care of behind the scenes for you so that you don't have to worry about the specific implementation. It's really just keys and values. There is an order of lookup so that you could actually have system-wide application settings, and then on top of those the user could save their own settings. Also, it is important to note that there are some limitations to QSettings that only appear on certain platforms, but you should take them into consideration on all platforms. One of these limitations is the fact that on Windows, the registry is case insensitive, whereas on the Macintosh operating system, they're case sensitive. So if you rely on the case insensitivity on Windows, your application is not going to run correctly on the Macintosh. Also on Windows, there are some size constraints. The maximum size of a key that you can have is 255 characters. The maximum size of a value is up around 64,000 characters. While you might not run into these limitations very often, it's important to keep in the back of your head because these limitations are ignored on the Macintosh and on Unix. When you move to Windows, you got to make sure that your keys are not too large. QSettings is a nice convenience that allows you to easily create a system where you can save user settings that will persist between runtimes. I hope this is valuable information that you can use to make your applications better and in a shorter time frame. Resources are a way for packaging application support files inside of your application binary itself. This means that you can distribute less files when you go to install your application on the user's machine. Oftentimes, you will need to use a number of image files or sound files or other support files in your application. Let's take a look at an example. Here we have the application example from Qt, and you'll notice that this application is going to require a number of icons that are going to be used on the toolbars and the menu bars. Now, one way and a classical way of distributing those files would be to have a subdirectory, maybe that when you install your program onto the user's system, you have an application directory, and then maybe you have a directory under that called images. This becomes cumbersome and error-prone and makes it much harder to update your application. The better way of doing this is to use the Qt resource system that is going to allow you to embed any file inside of your Qt binary. These files could be images, they could be sounds, they could be XML files, they could be anything. The Qt resources are going to allow you to make a file that describes a pseudo file system that's going to be contained inside of your binary. The way you do this is with an XML file. This XML file, it has a doc type of RCC. These are Qt resources. The XML syntax is very simple. In fact, as you can see here, it's rather human editable. We have one major tag called Qt resource, and then that has subtags of files. It's extremely easy. You could go ahead and write these files by hand if you wanted to. However, an easier way to create these files is by using QtCreator, which can natively edit this XML graphically. Let's take a look at how that works. This is the actual code involved in the Qt application example, which uses resources for all those images for the menus and the toolbar. We'll notice that there is a category here called resources, which holds our XML file. Here it's called application.qrc, which is the standard file extension for Qt resources. Now, while on the disk, this is a simple XML file. If we open it in Creator, we'll see that we get a graphical representation of the images. We have a root file system that has files with a directory called copy, new, paste, and so on. If we wanted to add a new file, we would simply hit the add button, and we can add a file or add a directory, here called prefixes. And we can simply go ahead and pick a file to include. And it could be any file, a text file, binary files, images, sounds, really anything. And likewise, we can graphically remove things from our resources. Now, the question you might be asking yourselves is, okay, so we now define this XML file, and Qt is going to take care of kind of compiling those files directly into our application binary. How do I access those files in the actual program? Well, that's actually very easy. There's this new pseudo file system that you can access that starts with :/. So anytime where you would use a file name, say to open a QPixMap, and you would give it a file name, say of images .png, now you can give it : images .png, and it will access this read-only pseudo file system that's embedded inside of your actual application binary. So to make sure that Qt goes ahead and compiles these files using your XML that you have defined or edited in Creator, you need to add something to your project file, your .pro. There is this new variable called resources. Just like in your file, you might have headers, you might have sources, you might have forms, you can now have one or more resource files defined. And once you add this to your project, QMake and the build system are going to make sure that your files are processed and packaged into the final binary. Now, we talked about these things called prefixes, which are like directories, so you can organize your files. So you might have some files in images and some files in sounds. And if you organize your resources into directories, it's going to be much easier for a maintenance programmer to go in and edit. Also, there's a concept of aliases, where you might have files in a directory, but they can be aliased to another name. So here you'll see that we have QtPNG that is in the images directory, but it also has an alias that's just called Qt. So to access this in the application, we can just say Qt. You might ask, well, how would that be useful? It's a little less typing, but what's the main benefit? Well, the main benefit is that you can actually switch aliases based on your locale. So when you go to internationalize your program, you can use different images or different sounds based on the locale of the Qt application. And inside of the application when you program it, you can simply use the cut alias, and that will map to the correct file for the locale. If you are using many libraries in your application, like you might have a static library that contains a number of widgets that you have defined as custom widgets that are going to be used in your main application. But you make a static library so you can reuse those widgets over and over again in maybe other applications. When you do this, you can compile Qt resources directly into the static object, and if you want to use them in your main application, you have to use this macro in main called Qinit resources, and you give it the name of the resource file. That's going to allow resources from that static object to be available to your application at runtime. You can also load these RCC files directly off the disk. Instead of having Qt automatically compile these files into your application binary, you can use this program called RCC, which is the resource compiler. And you can pass RCC your XML, and it will generate for you this binary blob called an RCC file. And you can actually load these at runtime using the static method QResourceRegisterResource. And it will read data RCC off the disk, and now all those files are available in the pseudo file system called : And these file names will actually work with any Qt object that takes a directory name. So it could be an image, could be a pixmap, could even be QDIR or QFile. Using resources is going to allow you to distribute less files to the user when you install your application on their system. This is going to make it easier for you to write your installer. It's also going to make it easier for you to upgrade your application on the fly in the future. I hope that you can use resources to make your life easier when writing your own applications. Finally, once you have your application written, you may be using resources, you are going to actually want to take your application binary and install it on another computer. And the question comes up, what exactly do I need to distribute with my application to have it run on the user's host system? There are two ways to distribute Qt applications. You can use static linking. And what this means is that the compiler is going to take all the symbols that you use from Qt, only the ones that you use, and it's going to compile it directly into your application binary. This is going to make your application library a lot bigger, but instead of having to distribute 2 or 3 Qt shared objects and your application, you only need to ship your application binary, a single executable. There are some downsides to this approach. First off is once you use static linking, you cannot have dynamically loaded plugins in your Qt application. And there's not much flexibility when it comes to upgrading Qt. And also the biggest limitation is probably in the licensing area, where if you're using the LGPL version of Qt, you cannot use static linking at all. You have to use shared libraries. So shared libraries are the second way to deploy your Qt application. This is something where you take your Qt application binary and you distribute it along with, say, QtGUI.dll, QtCore.dll, maybe QNetwork.dll, and you distribute these 5 or 6 files all at once to the user. What this is going to allow you to do is that those Qt shared libraries can actually be used by different applications on the user's host system. So if you have 2 Qt applications that need to run, the operating system will make sure that only 1 copy of the Qt shared library is in memory at any given time. This also allows you to have a smaller executable so that your application could be 3 megabytes worth of your own code, and then separately has shared objects goes the 15 megabytes of Qt GUI, Qt Core, and so on. Unfortunately, this means that there are a lot more files that you need to be distributing. Instead of just 1 file, now you have 5 or 6 files that need to be placed on the user's system. Some platforms, such as most Linux distributions, are going to have Qt pre-installed on the system. And what you can do in those cases is you can ship a dynamically linked version of your application and then have a dependency in the installer that says on Linux, say in your Debian package, that before installing your application, the user is going to need to install the Qt libraries from the system distribution. Luckily, Qt is entirely backward compatible. So if the Linux distribution installs a newer version of Qt than what your application was built with, your application will still run. The engineers at ICS, as consultants and trainers, suggest that shared libraries are usually the easiest and most flexible way of distributing your application. I hope you've enjoyed this sample of the Qt Essentials training course. For the full experience, including labs, a live instructor, and much more, I suggest you attend a full multi-day Qt Essentials training course taught by either ICS or any of the Qt training partners. For further information, please visit qt.nokia.com. Thanks for watching.